All right, example 4 with the sine law. It says the Confederation Bridge spans the Northumberland Strait and joins New Brunswick and PEI. From a point in the strait, the angle of elevation of the highest point on the bridge is 26.6 degrees. From a point 100 meters closer to the bridge, the angle of elevation is 71.7 degrees. How high is the bridge to the nearest tenth of a meter? So we want to start with giving a sketch of this diagram, getting an idea of what it's talking about. So I'm going to draw up here, there's a line that represents the bridge. And then I am down here, let's say looking up at this point of the bridge, somewhere here. So I am looking, and here is the ground. So remember, the angle of elevation is technically considering looking up at some point. So I'm down here on the ground looking up at this bridge. And this angle of elevation is 26.6 degrees. Now I'm going to walk 100 meters closer to the bridge. So here's the edge of the bridge. I'm walking 100 meters closer. So let's say this distance here would be 100 meters. And I'm going to look up at the bridge again. And this angle in here is 71.7 degrees. How high is the bridge? So what we want to do is we want to figure out the height, which is now going to create a right angle with the ground. And we want to find the height of the bridge. All right, so how do we go about doing this? Okay, so we have two right angle triangles, a small one and a larger one. But within both of those right angle triangles, we only have one piece of information. And in order to solve a right angle triangle, heights and angles, you need two pieces of information. So we need to know something else about either this right angle triangle or this right angle triangle. It doesn't matter. Okay, so let's call this length A and this length B. Okay, so that would mean this angle over here is A and this angle here would be B. Okay, it doesn't matter which of these two side lengths you figure out, you're going to get the answer either way. Okay, but once we have this side length, we can use side length A in this little triangle to find the height, or we can use side length B in this larger triangle to find the height. So in order to find this side length, I have the opposite side of this, so I'm going to work in this oblique triangle. Well, I have the opposite angle to side A. I have this length down here, which is 100, so I would need to know this opposite angle up here. And in order to find that angle, I need to find this angle here. Well, I know this other angle, so let's call this C up here. So I know angle ABC forms a straight line with angle, this other angle B. So if I take 180 degrees and I subtract that angle of elevation at that point, 71.7, I get an angle of 108.3 degrees. Okay, well, I also now need to figure out this angle up here. So to figure out that angle, so angle C up top there, or ACB I should call it, I'm going to take 180 minus 26.6 degrees minus 108.3, and angle ACB works out to be 45.1 degrees. So now I can set up the sine ratio to either find length A or length B, and it honestly does not matter. I have chosen to find length B. Okay, so I'm eventually going to work with this big right angle triangle here. So I'm going to take the sine of 45.1. Now I'm using my sine law in this oblique triangle over its opposite side, which is 100. I'm going to make that equal to, because I'm looking for side B, I want the angle opposite of that, which is 108.3. I'm going to go sine of 108.3 over B. I'm going to cross multiply and then divide by my remaining value. So my B value works out to be 134.0353. So I'm going to round this value to 4 decimal places. This is a safe rounding zone because I'm using this answer again to eventually find my height. Okay? You can either, if you round to anything less than 4 decimal places, then your rounding at the very end might be a little bit off. So it's important to either round to 4 decimal places or store this answer into your calculator. All right, so now I'm going to set up this just simple trig ratio. So thinking back to just right angle triangles from Math 10, I have this angle. I want to find the height, which is the opposite of that angle, and my length B would be the hypotenuse. So I'm going to go sine of 26.6 degrees is equal to the opposite, which is h, over my hypotenuse, which is what I just found. And so to solve for h, I'm just simply cross multiplying. The height of the bridge works out to be exactly 60.0 meters because it asks to round to the nearest tenth in the question. So my final answer is 60.0 meters.